Morning everyone, this is Sangeeta, Assistant Professor, ECE Department, SNS College of Technology. So in this video, we are going to discuss about one of the LC oscillator, Clapp oscillator. So let us have a small recap about the previous video, that is Hartley oscillator and Colpitts oscillator. So Hartley oscillator, it uses two inductors and one capacitor. The two inductors are connected in series. So the frequency depends on the inductor of the coil and the capacitor. And in Colpitts oscillator, it uses two capacitors connected in series and one inductor. So in Clapp oscillator, uh, it is a modified version of Colpitts oscillator. So this is the circuit diagram of Clapp oscillator. So the main advantage of Clapp oscillator is it is free from circuit fluctuations and temperature. So in this circuit, it is look like Colpitts oscillator, but it is the modified version of Colpitts oscillator. So as in Colpitts oscillator, one transistor acts as an amplifier and R1, R2 acts as a voltage divider, and there are two coupling capacitors are used in the base side and in the collector side, that is in the input side and output side, and the resistor Re and the capacitor Ce connected at the emitter side is used to stabilize the frequency, and VCC is applied, and it consists of feedback circuit. In feedback circuit, two capacitors are used, and that is three capacitors C1, C2 and C3 are used. That is compared to Colpitts oscillator, additional one oscillator C3, it is a very small capacitor in capacity. The working of Clapp oscillator is, so on switch on the circuit, the feedback circuit components produces thermal agitation, produces oscillations due to thermal agitation. So it is given to the base of the transistor through the coupling capacitor, where it is amplified, and the amplifier produces the output. So in feedback circuit, the waveform produces as 180-degree phase shift, and in the amplifier it also produces 180-degree phase shift. So totally 360-degree phase shift of oscillation produced. That is, it is the one of the Barkhausen criterion. The Barkhausen criterion should satisfy to produce sustained oscillation. So the frequency of oscillator is Fc is equal to 1 by 2 pi root Lc, and the capacitance value is, that is here there are three capacitors are used and three are in connected in series. So C is equal to 1 by 1 by C1 plus 1 by C2, 1 by C3. So here the value of C3 is much smaller than the other capacitors C1 and C2. So in capacitor, if the capacitors are connected in series, the smaller value only dominated. So the frequency of oscillation can be written as Fc is equal to 1 by 2 pi into root L into C3. So this is the final frequency of oscillation. And coming to the advantages and disadvantages of Clapp oscillator, it is very very high. It has a high frequency stability. So the frequency stability depends on a circuit, that is feedback components. Here the small u, because of C3, the high frequency stability is achieved, and it has the reduced effect of transistor parameters and better temperature stability. So the main frequency determining capacitor can be chosen with low temperature coefficient, and it has wide frequency range and lower phase noise. It provides a pure sinusoidal waveform compared to other LC oscillators, that is Hartley and Colpitts oscillator, and compact in design. Hope this video will help you to understand the Clapp oscillator working and how the high frequency stability is achieved. So this is the assessment time. There are three questions. The first question is, in a Clapp oscillator, the additional capacitor connected in dash with the inductor of the tank circuit. And the next question, that is, the answer is series. The next question is, the Clapp oscillator is an improved version of dash oscillator. So the answer is Colpitts oscillator. And the Clapp oscillator is widely used in dash frequency applications such as RF signal generators. The answer is high. So hope we will see in the next video. Thank you.